We've been looking at the way that heat engines, specifically steam engines, operate in the real world so that we can understand how a perfect or a steam engine at maximum capacity will work in an ideal world. We left off in the last video with James Watt inventing an improved Newcomen engine and developing that in around the 1760s, 1769. By the 1780s, 1790s, and 1800, the high-pressure steam engine was in general use in factories, on steamboats, and around 1800 to 1804, we begin to see the first steam locomotives on the railroads. So I'd like to talk a moment about how a high-pressure steam engine actually operates. And again, this will help you by pointing out the differences between how an engine operates in the real world and how the Carnot cycle operates. So let's look as an example at a railroad locomotive. The railroad locomotive's cylinder, this is what contains the piston. You see it mounted under the boiler at the front of the locomotive and has rods and shafts connecting the piston to the locomotive's driving wheels. You'll also notice what is called valve gear, and I'll explain that in a moment. But let's look first at the typical cylinder and piston arrangement on a railroad locomotive. You'll notice that the cylinder has two openings, and one opening is on each side of the piston. Above the cylinder is what's called the valve chest. And the valve chest, as you might imagine, houses a sliding valve. And this sliding valve is very important. Let's say we want the piston to go this way. The valve covers this opening so that the steam, as it's admitted from the boiler, fills this side of the cylinder and pushes the piston this way. So what happens to the steam that was on this side of the cylinder? Well, the valve has a small opening that allows this steam to vent to the atmosphere. Notice we're not condensing the steam. The steam, instead of being condensed, is being sent out to the atmosphere. And that turned out to be a very important development in locomotive technology. Now, when we want to switch the direction of the piston, this is what we do. We move the valve so that the other side of the cylinder is open to the atmosphere. The incoming steam cannot enter this half of the cylinder. Instead, the incoming steam enters this half of the cylinder and pushes the piston this way. At the end of the piston stroke, we're going to move the valve back so it looks like this, and now the exhaust steam goes out to the atmosphere. Incoming steam is blocked from this side of the cylinder. The incoming steam comes in here and pushes the piston this way. This is how a typical steam engine, which is of course a specific type of heat engine, works in the real world. This is not a perfect heat engine. Now we can combine this with an indicator diagram and develop some ideas about the operation and thermal efficiency of a steam engine. Again, the type of steam engine I've just described appeared in factories around the 1780s and appeared in the first experimental locomotives around 1800 to 1804. In the next video, we're going to combine the indicator diagram and the steam locomotive to develop some ideas about tracking and monitoring and understanding the efficiency of a steam engine.